Good evening, everyone. Thank you for being here tonight. This is the last night we have our webinar series. My name is Juliana. I'm assistant professor and beef extension specialist with Oregon State University. And it's my pleasure to be organizing this webinar series. Our main goal is to provide information and discuss about wildfires with focus on preparedness prior to fire season and how to care for livestock during wildfires and during smoke exposure. This webinar series are part of a larger project funded by the USDA NIFA, which focuses on wildfire smoke exposure and the impacts on animal health and performance. So for tonight's talk, it will be presented by Dr. Amy Skibiel and Dr. Pedram Rezamand from the University of Idaho. They are part of our group. And tonight they'll be talking about the ongoing and future research projects that focus on wildfire smoke exposure and how that impacts cattle health and performance. So they'll be answering questions at the end of the talk. So if you have any questions, please type your questions at any time on the Q&A box, which should be at the bottom of your screen. And one more note is that webinars are being recorded and the first two nights are already online. So they are posted on YouTube and on the OSU extension website. And they will be also posted on our website later. So I'll put this information in the chat box. Pedram and Amy, thank you very much for joining us tonight and welcome.
Hello. Thank you so much for having us.
Great.
So I'm Dr. Amy Skibiel, an assistant professor at the University of Idaho, and my area of expertise is in lactation and environmental physiology.
I'm Pedram Rezamand. Been with the department for about 15 years. I'm a dairy nutritionist by training, and I focus on inflammation.
So we're going to do things a little bit differently tonight. We do have some slides that we're going to show later on, but we're going to have this be a little bit more conversational. So we're just going to post a series of questions and kind of do like a Q&A between the two of us. We'll talk about a little bit of background about wildfires and wildfire smoke specifically, which is what we study and why we should be concerned about it. And then we will talk about some of the research that we have been doing and that's ongoing, and then talk a little bit about some future directions. And then we'll kind of end up with what recommendations there are for producers at this point in time. And some of that was discussed over the past two nights in the webinar, but in case you weren't able to make it to either of those, we'll just go through a few of those points of things that producers can do to kind of prepare for wildfire events. So with that, we'll start off, and I'm going to ask Dr. Rezamand the first question. In a general sense, why should we be concerned about wildfires?
In a recent time, if you look at the number and frequency, basically of wildfire events, there have been a significant increase. If we look at the acres that are burned every time, these are also getting larger and larger. So basically, there's a threat directly by the fire to the land and the structure and what's on it. And these are getting worse and worse, especially in the Western United States, where there are close to 4 million cows and producing close to about 40% of the United States overall milk production. This is a direct impact. There's also an indirect effect here, and that is because of the smoke that is produced by these fires that can travel sometimes 50 to 100 times more than the area that is being burned. Basically, the most recent example would be the fire in Canada, and we saw the results of the smoke in the state of New York. This is going to basically get worse and worse because experts predicts that there's further increases in number of the large wildfires and longer seasons as we move forward. We can tie this up to lower rain and snow and faster snow melting and drought seasons as well. So that will lead us to my next question. What do we know about the effects of wildfire smoke inhalation in human and other species?
So it's probably not surprising that most of the research that has been done to understand the effects of wildfire smoke exposure has been done in humans in a biomedical context. And so in humans, the literature pretty much agrees that there are increases in lung disease from exposure to wildfire smoke. There's also an increase in hospitalizations from pulmonary ailments during smoke exposure. And I should mention too that these studies have been looking not only at the time of exposure, but also looking at lag days after exposure. So we can see if there are persistent effects over time. And those studies have shown in humans that some of these effects that we're seeing can persist for at least a week, if not longer, after wildfire smoke exposure. In the human literature, there are also associations between wildfire smoke inhalation and cardiovascular events, as well as cardiovascular related hospitalizations, and an increase in premature mortality. In other species, so in wild species and in domesticated species, there are a handful of studies, but we still don't know a whole lot about wildfire smoke effects. And that's exactly why we're studying them. So there's a study done in dolphins, and this was done on the population of dolphins that is housed in the San Diego Bay. They're actually part of the US Navy. And these researchers looked at 2 wildfire events across a couple of years and found that there were changes in immune cell populations in the blood of the dolphins during and 1 month after wildfire smoke exposure. And those dolphins actually also had an increase in carbon dioxide levels in the blood. So together that suggests that there are changes in immune and lung function in these animals that are exposed to naturally occurring wildfires. There's a study in orangutan showing that there's a change in energy metabolism during a wildfire, and the researchers think that might be because of an increased immune response. And in cattle, there are a couple of studies, one on ambient particulates, which are one component of wildfire smoke, which we'll get to in a little bit. So ambient sources are from non-wildfire sources. It can be from dust on farm, it can be from, wind blowing things. And so these researchers looked at associations between just the ambient levels of particulate matter along with temperature and humidity, which we know affects cattle production. And they found that there was a decrease in milk yield and an increase in somatic cell count in the milk when ambient PM was high. It happened that during their data collection, they did have a small wildfire event. And so they both included and excluded that wildfire event from their analyses. And so when ambient PM and wildfire PM was increased, they find these associations. And that work was done, it was published a couple of years ago, which was about a year after we started doing our work here in Idaho. So it kind of nicely dovetails with what we've been doing. There's another study in calves on PM, which is a particulate matter, again, a component of smoke from dust. So again, from non-wildfire sources. And that had an effect on risk of pneumonia in calves. And again, changes in immune cell populations indicating an immune response. And so those studies really encapsulate what we know about wildfire effects. And it's worth noting that the last study that I mentioned, or the 2 studies in cattle, really are not focused on wildfire smoke specifically. And we know that there's a different composition of pollutants in wildfire smoke relative to other sources of air pollution. And so it is important to be studying air pollution from wildfire smoke specifically. So next question is from me. Why is it important to study wildfire smoke in the context of animal health and production?
As I alluded earlier, there's a large number of cows, dairy cows in specific, in the Western United States. This population produces a significant amount of milk relative to the overall national milk production, close to 40%. So we very much impacted with the wildfire events that happened on the western side of the country. And these are getting just longer and larger in terms of the acres burned. And this is just getting worse. So it's important to study the wildfire smoke inhalation and its effect on animal health and productivity because of our geography, where we are located, and the number of cows and the amount of milk that we produce. There's data on health effects inhalation in humans, but as Dr. Skibiel pointed out, there's not a whole lot of prior work in cows, specifically in dairy cows, even though we believe that exposure for dairy cows is going to result in worse health outcomes relative to that of humans and other species that could stay indoors. With that, I'm going to ask Dr. Skibiel a little bit more about the type of components that we find in wildfire, and if there's any particular interest in any single one of them, and why.
That is a great question. So wildfire smoke composition is complex. So wildfire smoke consists of both gaseous and particle components, and those are going to vary depending on the fire behaviors. Again, Dr. Cruikshank talked about this a little bit in last night's webinar. It's also going to vary depending on the type of fire fuel burned. So what type of vegetation is burned, for example. But typically what we see in wildfire smoke is going to be gaseous components like volatile organic compounds, carbon dioxide, nitrogen dioxide, sulfur dioxides, and so on. Also aromatic hydrocarbons. And then particulate matter. And particulate matter is both solid particles and liquid droplets that are suspended in air. And the particulates in smoke can be categorized based on their size. So PM10, for example, are the coarse particles, and PM2.5 are the fine particles. And we're focused mostly on PM2.5, and a lot of the literature has focused on PM2.5 in humans as well, because it's thought to be the component of smoke that is the most hazardous. And the reason for that is that particulate matter, the PM2.5, is so small that it can travel through the airways and deposit in the lungs, and then it can cause problems within the lungs. PM2.5 can also cross the lungs and enter into the bloodstream to circulate around the body and cause problems across the whole body. So it's thought to be one of the hazardous components of smoke. And for this reason, that the EPA actually considers PM2.5 to be a criteria pollutant, which means that there are established standards for human outdoor exposure. So for humans, that exposure threshold is 35 micrograms per cubic meter, and just kind of keep that number in mind, because we'll talk a little bit later on about some of the levels of PM2.5 that we see in smoke. So if human outdoor exposure exceeds 35 micrograms per cubic meter of PM2.5 across a 24-hour period, that can be hazardous to health, especially for sensitive populations. So with that, we're going to get into some of the research that we've been doing. And so I would like Dr. Rezamand to kind of follow up with that on what we know about morbidity and mortality in cows related to their exposure to wildfire PM2.5.
So our recent work, and also some of the literature, few cases that we could gain access to, show that there's an increase in cow illnesses, both in terms of the number and the severity. Our own research also shows that there's a increase in terms of calves in their mortality rate, and This is matching what we know about in human literature. There's evidence in human literature that shows increased mortality rate. For example, in Australia, when they studied about 20 years of data between 94 and 2014, they found out that there's about 5% increase in mortality rate in humans related to wildfire smoke inhalation. So most of our focus in recent work has been basically to delve into mechanistic behind these increased rate of mortality and morbidity, both in calves and in mature adult cows. So with that, I'm going to ask Dr. Skibiel to talk about some of the specific effects that we see in terms of productivity, metabolism, and immunity of dairy cows.
Sure. So I'm actually going to share the screen because we have a few slides to share with you. Okay, so hopefully trying to get it in to the presentation mode. There we go. Okay, so hopefully everybody can see that. So we'll start with production. And basically what we did in these studies was we took measurements from cows on various variables that we'll show you, both before exposure to wildfire smoke event, during a wildfire smoke event, and then after a wildfire smoke event. So this work was done in the summer of 2020, and in that particular summer, we had one wildfire smoke event that lasted for about 7 days. And that resulted in daily PM2.5 concentrations up to about 300 micrograms per cubic meter. So if you recall from our earlier conversation, human outdoor exposure limits are 35 micrograms per cubic meter over a 24-hour period. So we're quite higher than that with this wildfire smoke event. And interestingly, one of the effects that we see when cows are exposed to this wildfire PM2.5 is a decrease in milk yield. And as I mentioned earlier, we also looked at lag days, like other researchers have done for human studies. So a lag day of 0 means the day that the animal is exposed to those environmental conditions. And as you can see on the slide here, this figure is showing a decrease in milk yield with that increasing PM2.5. I'm not showing all of the lag days here, but we looked up to a lag day of 7. So this would be 7 days after the last day of exposure. And what we see here is that milk yield is still lower with higher PM2.5. And then this figure on the right just shows the change in milk yield for every 100 microgram per cubic meter increase in PM2.5. So this is just showing across all of those lag days. So again, at a lag day of 0, which is the day of exposure to those conditions, there's a drop in milk yield of about 1.2 kilograms per cow per day for every 100 microgram per cubic meter increase in PM2.5. So that equates to roughly about 3 pounds of milk per cow per day. Again, for every 100 microgram per cubic meter increase in PM2.5. Now, recall, in this particular summer, the PM levels got up to about 300, so we'd need to multiply that number by 3 for the days when PM2.5 was much higher than 100 micrograms per cubic meter. If we look up to lag day 7, we still see decreases in milk yield up to about 1.5 kilograms of milk again per cow for every 100 microgram per cubic meter increase in PM2.5. So really across the whole range of exposures, so during the time they're exposed and up to 7 days after the last day of exposure, we're seeing decreases between about 3 to about 8.5 pounds of milk per cow per day that is lost. We also found that milk protein concentration was slightly lower. Again, we find 0.14% decrease in milk protein with every 100 microgram per cubic meter increase in PM 2.5. So we also looked at changes in metabolism, and we find that on the day of exposure, there's a decrease in blood urea nitrogen, and this is a measure of protein breakdown in the body. So there's a decrease in protein breakdown. We don't see any changes in glucose or beta hydroxybutyrate, but we do see an increase in non-esterified fatty acids. So there's clearly a change happening in the cows when they're exposed to wildfire smoke. And these changes actually are opposite with further exposure days. And this could be having an effect on milk yield and changes in composition that we observed. We also measured blood carbon dioxide, and as you can see in the figure here, there was an increase in carbon dioxide in the blood with increases in the concentration of PM 2.5 from those wildfires. And this could be indicating that there's a problem with lung function, but it also might just be occurring because there's carbon dioxide in smoke. And so if they're breathing in that smoke, they're going to be breathing in that carbon dioxide as well. But we also find that there's an increase in respiration rate when both particulate matter and temperature humidity index is increased. And that should kind of make sense because when it's hot outside, the cows might be getting to the point where they're panting, so they're respiring a little bit more frequently. And that's a problem during wildfire smoke because the faster an animal is breathing, the more of that air pollutants the animal is going to be taking into their lungs. So we also looked at changes in blood hematology, and this was largely driven by that study in dolphins that I mentioned earlier. And so we see delayed effects on changes in immune cell populations in the blood with wildfire smoke exposure. So we don't see any effects until a lag day of 3, which means 3 days after the exposure, we start to see changes in immune cell populations in the blood. So we found a decrease in red blood cells and hemoglobin, and an increase in eosinophils and basophils. And so there appears to be an immune response happening when these cows are exposed to wildfire smoke, and that is happening about 3 days after exposure. So we've also done some work with calves, as Dr. Rezamand mentioned, and we've looked at some of the same variables in calves that we do in cows. But we do see some differences in how calves respond to wildfire PM inhalation relative to how cows respond. So we do see changes in calf metabolism. We see increases in glucose, decreases in beta hydroxybutyrate, and an increase in NEFA, which is what we saw in cows, that last one. And so again, calves seem to be affected metabolically by wildfire smoke exposure, but the specific metabolites that are altered are different relative to cows for the most part. The only exception is with NEFA. When we look at hematology, we also see delayed effects on immune cell populations in calves, but some of the effects we see are a little bit different than in cows. So in calves, we find an overall decrease in white blood cells, and these are important immune cells that circulate around the body. We see a decrease in specific white blood cells like neutrophils and eosinophils, as well as lymphocytes. Looking at calf health scores, and I should mention, I forgot to mention this on the past couple of slides, but with the calf study, pretty much all of the effects that we're seeing are an association between PM 2.5 exposure and temperature humidity index. So it seems like that combination of increased PM 2.5 in the air and THI are problematic to calves. So as far as health scores go, so we've done health scoring on the calves to look at things like discharge from the nose and the eyes, as well as cough scores, which might give us an indication of whether or not there's some irritation going on from exposure. And again, we find after a few days lag, an increase in eye scores. So we're seeing more discharge, more tearing from the eyes, and an increase in coughing from those calves. And that could potentially predispose them to infections such as pneumonia. So this past summer, we also started to conduct lung ultrasonography on the calves so that we could look at changes that are occurring within the lung tissue. And we basically just score these as indicated here. I'm not going to go through what all the different scoring is, but it basically gives us an indication of whether or not there's a likely infection going on, or if those infections are potentially leading to lesions down the road. And so what we find is when there's these increases in PM and THI again, we also see an increase in those lung ultrasound scores. And this image is just showing what one of those ultrasound images are that we captured in our calves. And we can see here that there's some consolidation, which is indicated by this white arrow on the left. And again, that's just an indication that that animal either had an infection or they currently have an infection in the lungs. Okay. So that kind of summarizes the work that we have been doing together over the past couple of years. And Pedram is now going to talk about some of the research that we are currently working on.
So our most important ongoing project deals with the in utero effects of wildfire smoke. Basically, what we're studying is to look at the calves whose mothers were exposed in summertime to wildfire smoke, and we're looking into impacts on their health, the calves' health and metabolism and growth measurements. Like I said, these are the calves that come from cows that were exposed last summer. And we are basically looking at them, and we also maintain herd as a negative control in a geographical area where the cows were not exposed. So those baby calves are coming from mothers that were not exposed to wildfire smoke inhalation, and using them as our control. We have established through another collective efforts a website, and we have several social media presence that we will show you in a second, where we basically put all the information that here you go. So this is the website that we update on a weekly basis. We have summarized our projects that are ongoing and or upcoming. We have our extension articles posted, as well as our peer-reviewed publications, as well as the presentations, including the last 2 nights. In addition, we have an active presence in social media such as LinkedIn and Instagram, that we post information, update information that we already have on there.
And just to add to that, so the website is livestockwildfirehub.org, and we can put that in the chat function as well, so you have access to that. So this is our landing page here, and if you scroll down to the bottom, you can also access those social media accounts. that we're on. So the purpose of this is really to provide resources on the ongoing research on this topic, as well as providing resources for producers. This is a collaborative effort by folks here at the University of Idaho, as well as Oregon State University. And if you've come to the webinars the past couple of nights, you will recognize these faces because they are the same ones that are involved in this research and extension group. So please check out that website. We will, as Dr. Rezamand mentioned, we are continuously updating information. We will be posting shortly a list of steps for preparedness and responses to wildfires and wildfire smoke events. So stay tuned for continuous updates on this site.
So this brings me to my next question. Where do we go from here? What are the questions that we are trying to answer as we move forward?
So, as I mentioned earlier, we're really just scratching the surface and understanding how wildfire smoke impacts our animals. And of course, the more questions we answer, the more questions we generate. So we're really interested in looking at long-term effects in cows and calves that are directly exposed to wildfire smoke. As I mentioned, we see effects up to at least a week after the last day of exposure, but we haven't looked beyond that yet. So I think we really need to understand what the long-term impacts are on the animals from wildfire smoke exposure. We're also interested in testing different strategies on farm, such as housing facilities, if there are differences in exposure levels depending on the type of housing, and also trying to test cost conscious and effective solutions for producers on farm. So be on the lookout for research coming out of our group over the next few years as we work on those questions. We're also interested in looking at controlled exposures so that we can, expose animals to a specific level of PM 2.5 and decrease or completely omit any other factors that might be having an influence on production and health, like temperature, as I mentioned earlier. And lastly, we're also thinking about working on forage yield and composition. So we have proposals in to hopefully be able to fund that research, because obviously that's going to have an effect on crop production, on rangeland production potentially, which impacts animals indirectly. So with that, I will have Dr. Rezamand kind of finish up with giving some recommendations or current guidelines that producers can follow to help protect their herds during and after, I should say before, during and after wildfire smoke events.
So I think I'm going to start with asking everyone to basically look up the webinar that was provided on Wednesday. There were a lot of excellent recommendations for producers in webinar that Juliana and Jennifer provided yesterday. Just building on that, it's important that we clear brush and debris around the area. We leave defensible around the land so we can actually better protect. We should make sure that the animals have access to water. This was discussed yesterday. It's extremely important that the animals are able to hydrate. This is important even at the cellular level, simply because a hydrated animal will be able to better tolerate the heat and smoke inhalation and PM that are inhaled through the wildfire smoke. We obviously want to minimize the physical activity to the extent possible. And if there's a possibility, we should be also thinking about putting our animals indoor. For areas that use indoor structures to maintain animals, it's important that we check into the air filtration. And this is one of the areas that we actually going to be looking into in our upcoming projects where we test different housing type. One of the areas that we'll be looking into is basically testing this question whether if it's possible to use particular type of air filtration in indoor facilities where we could actually have reduced exposure of animals, especially younger animals that are in stress because of say transition period or because of the transportation. These are animals that are already stressed, and as we learned through the webinars last few days and today, the reactions are inflammatory based, and whatever we do to reduce those reactions in a controlled fashion, the animals will benefit. One of the areas we will be also looking into, as Dr. Skibiel alluded, is the veterinary interventions that we have. Because these reactions are inflammatory based, we are thinking about testing various forms of anti-inflammatory medications to see where we can actually have a response, but in a controlled fashion to this event as much as we possibly can. With that, I think we are ready for any question that audience may have. And thank you for the opportunity for us to share our work with you today.
And I'm going to go ahead and put the website in the chat.
Thank you, Dr. Skibiel, Dr. Rezamand. I think we do have a question on the Q&A box. So if you don't mind to go ahead and read that question and then answer it, because the question will not show in the recording. So it would be really if you can read it.
The question is, yep, that's it.
There we go.
What is the future of research on cattle exposed to wildfire smoke? What do you think researchers should focus on in the next couple of years to attenuate the short-term effects of smoke on cattle health and production, different nutritional strategies, facilities, and so forth? So I'm going to let Dr. Skibiel to work on the first part of it, and then I'll provide some answer on the second part of this.
Yeah, thank you for the question. Those are questions. Those are excellent questions. And they're really the $1 million questions, right? What do we do about this problem? Because it's not going anywhere. And we're trying very hard to come up with tangible solutions that are practical at the on-farm, at the farm level. And so I think moving forward, it's important to understand, again, try to test these different solutions on farm. If there's a way that we can minimize exposures, or we can, provide some kind of supplementation, whether that's in the form of a pharmaceutical intervention or a nutritional one, to mitigate the effects when they happen. I think, as I mentioned, also it's important to study long-term effects. We had to start somewhere. And so the obvious first place to start is just looking at short-term acute effects. But we know from the human literature and from some of the research we've done already that these effects are likely to persist potentially up to a month or several months after exposure. And so armed with that information, we can make informed management decisions on farm. So I think those are two big areas we need to work on. And I think the third is the forage side of things. And that is to get out there and measure the growth, the composition, the nutritional quality of forages and vegetation in rangelands during and after smoke exposure.
So building on that, I think I should remind everybody that because these are inflammatory based reactions, and we all know that inflammation and oxidative stress are basically hand in hand. In terms of nutritional strategies that one needs to consider, proper nutrition, proper plan of nutrition is extremely important, besides the hydration that we pointed out a couple of times so far. What I mean by a proper plan of nutrition is a diet that is appropriate for the physiology of the animal relative to the production, whether it's beef animal or dairy animal, relative to its growth or relative to its milk production and component production. We have to make sure that they're receiving proper level of vitamins and minerals that are directly involved with redox reaction. These are tools that the animal will use in terms of balancing against antioxidants, and that will basically enable the animal to fight uncontrolled inflammatory responses. So I think it's even more important, knowing where we are, that we properly balance our antioxidant in the diet and make sure that different forms of free choices of some of these minerals and vitamins are available for high producing animals specifically. And we also need to make sure that the water, clean water, fresh water is always available, and encourage higher intake of water, especially when we approach summer month, is extremely important. Obviously, we have different strategies to fight back in terms of diet against heat stress. Some of those recommendations seem very appropriate when we think about the association of thermal stress and wildfire season.
It looks like we might have another question in the Q&A. Do you have any thoughts about grazing animals? Is there any benefit to keeping animals in a barn, knowing most are essentially open ventilation? That is an excellent question. Yeah, this is one that I think we're going to have to test. I would imagine if you have an animal indoors and it's open ventilation, it's really not that much different than grazing on a pasture. And so I don't know if Dr. Rezamand has anything to add to that.
Sure. I think one part that makes a difference between grazing animal and animal kept indoor is the physical activity. Usually animal in rangeland and pasture will have to walk to collect their feed, and bringing them indoor, even though it's the same air they're breathing, is minimizing their physical activity. That could be of some benefit. The other benefit is that in an indoor setting, one could provide, as I said, free choice, additional minerals and vitamin supplementation, as well as water troughs. This is important that in those situations, water intake is maximized as much as possible. It's a bit harder to do it in a range and pasture in a short amount of time, but it's logistically speaking, it's a bit easier to do in indoor facilities.
Yeah, that was a good answer. And I would add that if you have the option of bringing animals to a barn, there's also as you guys also mentioned earlier today, the THI, right? Like a lot of influence between the heat stress and the fire. So if it is a fire during the summer and you have the option to bring those animals in, I think it's beneficial too.
Yeah, and I think as far as temperature goes, it kind of depends on the barn structure too, because they can get pretty hot inside too, depending on how many animals and the ventilation and things. So those are all considerations. It's complex, and we still need more research in those areas for sure.
Yeah, I actually do have a question, and I think I'll invite for a little bit of speculation. You guys were talking about the in utero study, so we know there's the monkey hazardous studies that in California with the, I can't remember which fire, but the bad one, I guess 2018, where there was increase in abortion when those monkeys were exposed to smoke during early gestation. So there was an increase in abortion for those female monkeys. And also, I don't know if you're familiar with this one, but there's some studies in Brazil with pregnant women that had abortions and preterm birth after being exposed to smoke. So I was just thinking, like, with those two information in mind, and with the project that we are all working, if you can offer a little bit of what you're expecting to see.
Sure, I'll start, and I'm sure Dr. Skibiel will add on top of that. We are learning that because of exposure, there's change in lipid metabolism. We can see it in changes in non-essential fatty acid in circulation, BHP, glucose, other measures of lipid metabolism. We're working on measuring fatty acid composition of immune cell component that we see increased over the exposure on the day or afterward. I suspect that there's a change in oxylipids, and this includes prostaglandins. Prostaglandins have a significant impact on reproductive performance. And I suspect, this is just a speculation, we haven't reached that level of our research yet. I'm hoping we get to this point about next year, this time, that the changes in oxylipid profile of exposed animal versus unexposed animal will lead to some understanding, because I suspect the PGF profiles will change, and that will have an impact on maintenance of pregnancy.
And I'll just add too, and this is also kind of speculation because we don't really know a whole lot about this. But as you mentioned, Juliana, there are studies in humans showing lower birth weight babies for the same gestation length, abortions, things like that. And one area of interest of mine is the ability of these particulates to cross the placenta. And so if the PM 2.5 is having a local effect on the lungs, which we know is occurring, and is having systemic effects throughout the body through circulation in the bloodstream, I think it might be likely that they're also crossing the maternal fetal barrier and could be influencing placental function potentially. Again, this is speculation. It needs to be tested, empirically. But I think there are likely several things going on physiologically that's contributing to that, and none of it has been studied yet.
That's good and bad for us, right?
Right.
lot of questions to answer.
Yeah.
I think we do have one more question on the Q&A, if you guys want to read that one and answer.
Sure. The questions reads, as we are well into hay harvest season, are there any thoughts on the effects of smoke on hay or feed preservations? I have recently heard of a farm with hay which is spoiled from smoke. We suspect there is an impact on both the yield per acre, so biomass per acre, and we also suspect significant changes in composition. We are hoping that our current proposal, pending proposal with the Western Sustainable Agriculture and Research and Extension will fund that proposal for us, where we basically go out, and in this proposal, we are attacking two major components: corn for corn silage and alfalfa. These are the major components of dairy diets. So we're starting there. We are hoping to test this question, basically, what are the differences in terms of yield per acre and also the composition. Once we accomplish this first phase, our next phase will be to look into the animal performance that are fed from different sources, exposed and unexposed feed items. And that will give us the ultimate answers as far as production goes. If we buy stuff that are exposed, how would they affect the production and composition of the milk?
Yeah, those are going to be the new chapters, right? There is some studies going on with grapes in Oregon and how how smoke and smoky days so affects the cycle production, but I'm also not familiar with anything like necessarily hay or grass, but I would suspect there's an effect for sure.
We have, as you all know, potato is strategically important for the state of Idaho. So there's an ongoing project, very new, just started a few months ago, that looks into potato preservation, storage condition that are exposed or not exposed. This is just started a few months ago. One of our colleagues in plant science in Southern Idaho. So the impact seemed obvious. We just have to dive into details and test hypothesis in a controlled setting so we can actually recognize individual contributing factors, causal factors.
Yeah, with the ultimate goal of generating solutions. Yeah.
Yeah, exactly. It's a long path, which is good. Job security, I guess. Well, I don't see any more questions on my side. I don't know if you guys got anything specifically on the chat. Okay.
Yeah.
So I think we're good. I would like to thank you both again. Thank you very much, Dr. Skibiel, Dr. Pedram Rezamand, for tonight talk. I think it was really nice to hear a little bit on the research plans and where all this started, right? I think it's interesting how we're neighboring states and we were not working together, and now suddenly this thing brought us together. So I think it's really interesting to think about how research in different locations also try to address the same problem, right? So I think it's really cool. So thank you very much. I put on the chat the website. So contact information is out there. I'm sure if you guys have any questions later for us or for Pedram and Amy, you can reach out directly to them or to me, and I'll forward the emails. And with that, I just want to say thank you to everyone one more time for joining us tonight. I hope you all have enjoyed the webinar as much as we did putting it together. Everything is being recorded. The 2 webinars from the last 2 nights are already online. I'll be working on the editing for this one, and hopefully by next week it's going to be up and running. So you guys can just access our website and should be there. As I mentioned earlier, this webinar series is part of a larger USDA NIFA funded project, and this webinar series are going to be provided on the next 2 years. So it's a project of 3 years. I'm trying to think. So hopefully next year around the same time, we'll be providing this webinar series again with more information and with more research update to you guys. So with that, I hope to see you guys next year, and please feel free to reach out if you have any questions or anything later. And that's it. Good night. Thank you all. Bye.
Thank you.